Okay, 10-1, arcs and sectors. Okay, well, obviously it's dealing with what? What is this? A circle. Okay? I said this is our circle unit. We did area and perimeter. Yes?
Yes.
And then we did equation of a circle. And now we are going to do area and arc length of a sector. A sector is a portion of a circle. So, what in your world is a sector? A piece of pizza. Could be a sector, yes? This could be a piece of pizza. Because this right here, this in here is a sector. But guess what? This whole thing is also a sector. Because it's part of the circle. A pie, a piece of pie would be a sector, but not the pie itself. Because the pie itself would be a circle, correct? What about Pac-Man? Does it look like Pac-Man?
Yeah, a little bit.
If you took away.
Like this is the mouth?
Yeah.
Okay.
Draw some teeth in there.
Anything else?
He doesn't have.
It does. Doesn't it?
Okay. So any portion of a circle is known as a sector. Okay? So we have arc lengths. This arc between A and B. So it would be A, B, and since it's an arc, guess what we draw all over it? An arc. Okay? That is known as a minor arc. And I feel like I'm writing really small. Is that too small? Okay. So that is a minor arc. Well, what do you think the major arc is then? The rest of it. And I'm going to name it ACB. ACB.
ACB.
Yep. Why would I name it ACB? Because AB would be like this, right? So if I want A is C in between B, so it needs to be in the order that it falls. It's called a major arc. And why is one major and one minor? One's big, one's little. Okay. This top arrow points to, this is called the central angle. And there are two of them, because couldn't I do an angle here too? Yeah. Oh. From P to B, what would that be? A radius. So PB, segment PB, and also PA. Okay, those are radii. Radius is one, radii is multiple. Okay. Oh, I have one here too, don't I? It's right here. Oops. Center goes first, doesn't it? Well, I didn't say it was a review. So I'll erase it off of here since I have one to both. What's P? The center. Okay, and it's of circle P. That's how we name it, right? So that is it. Okay, those are the parts of a circle. A sector is the portion. So here, this is known as a sector. And also, in this circle, there are two sectors that make up the whole circle. Do you see that?
No.
Do you not see that it's cut into two pieces? Like here's...
Like the whole thing.
Yes. These two pieces, if put together, make a whole circle, yes? So there are two sectors that make that whole circle. When I have a pizza, there's 8 if I got a large pizza, right? right? Isn't there 8 pieces? Okay,
It was like 16 pieces.
so the total measure of a circle is how many degrees? 360. What is the equation for the circumference of a circle?
C equals R pi radius, R times height.
Isn't it 2 pi r?
Yeah.
Okay. You're supposed to know that. Okay, so if a total circle is 360 degrees and the circumference is 2 pi r, how would I find S? Arc length equals S. How would I do that?
Well, the total circumference is,
Isn't this a fraction of the total?
yeah.
Okay, so I'm going to rewrite it like this. So I can say like S is some fraction of the circumference. Bless you. Bless you. Of a circle? Well, isn't N theta, we're going to call it theta, that central angle, isn't that a fraction of how much? What's the whole thing?
17.
What's the whole thing? 360. Okay, those two fractions should be equal, shouldn't they? Shouldn't those two ratios be equal? Think about our ratios and our similar things. So this length from here to here of S to the circumference should be the same ratio as the theta to the whole 360. So if I was going to solve this equation for S, got it? So this is divide by circumference. So to move it over, I would what? Multiply. Can I just write C now? So I'd have theta times C over 360. We're coming up with a formula to find this length, guys. Okay, well, what is circumference? So we have theta times 2 pi r over 360. 360 degrees. Can I reduce that at all? The 2 goes into 360, doesn't it? Yeah? So 2 goes, that's a 1, right? And half of 360 is?
It's not 130, it would be 180.
It'd be 180. I was getting worried there for a second. So I have theta times pi times r over 180 gives me S. And what did S? What was S? Arc length. You will also hear or see it called sector length. Or they'll say the arc of the sector. Okay? So there's our formula. Right there. Did we make this formula with things we already knew? Yep. What we just did is known as deriving a formula. Now, are you ever going to have to do it again?
No.
Nope, you're never going to have to do it again because do you already have it? Yes. Okay, what is theta? What did we call that? The central angle. So theta is the central angle. If you want to abbreviate, you can just put an angle symbol, right? What's R?
Radius.
Radius. Pi is pi, right?
Mhm.
And 180 is 180. So there's your formula.
So that's how to find the arc length,
That is how to find the arc length.
so I don't really need the S in there.
Well, that's the variable we say for S. They'll say find S. That's what S stands for, is arc length. Because it's a lowercase s for sector. So that's why we call it sector length sometimes. Make sense? A little? Okay, so what is the measure of the angle APD? So APD. So this angle right here.
Major arc.
It is a major arc, but that's not what it's asking. It's asking for the measure. This has nothing to do with the front.
You just add them up and subtract them by 360
Why?
because it's an angle and it's
Right. This circle is cut into 1, 2, 3, 4 angles, yes? So shouldn't we be able to add these three up and subtract it from 360?
yeah.
Yeah. So we have 360 minus 43 plus 73 plus 104. And you notice I put that in parentheses, so that means I have to do it first, right? So this is 126, isn't it, the first two?
I think it was 160.
Oh, I carried a 1 when there's not a 1 to carry. So 116? And 104, so that makes it 220.
Mhm.
So 360 minus 220
It was 140.
is 140. So the measure of angle APD is 140 degrees. That had nothing to do with what we did on the front page, did it? Did it have everything to do with stuff you already knew? Okay. So what is the length of AB? So here's AB. So is that a sector length? Yes? Do you see how this is an arc up here? Not a good one, but it is, right? So S equals, what was our formula that we're going to fill in from the other page?
Theta pi R over 180.
Theta pi r over 180. So AB, the arc AB equals, well, what's theta?
Angle.
So what's the angle? 73. Times pi times, and what's the radius? 4, because it's right there on the radius, isn't it? Over 180. Okay, well, I can multiply 73 by 4 and then reduce, but could I reduce first? Should I reduce first? Yes. Okay, so 4 goes into 18. How many times? 4. Carry a 2. So 4 goes into 20. How many times? 5. Okay. Well, 73. Does anything go into 73? No. So, and 73 definitely doesn't go into 45, and 45 definitely doesn't go into 73, does it? Nope. So my answer exactly is 73 pi over what? 45. Could I put that in a calculator and get an approximate? Yes. But exactly, it's that. Make sense? Do you want me to put it in a calculator and get what it approximately is? So 73 pi, not E, pi divided by 45. So approximately 5.1. And if there were units on the floor, would I put the units on there?
Mhm.
Yes, that's a measurement. That's inches, centimeters, something. Okay? So that using that formula is pretty straightforward, isn't it? You just use it. Okay, so what is the arc length of BD? I want you to try that on your own. So did you add 43 and 104?
Yeah.
Okay, we had to add those two because B to D is that whole thing, isn't it? Okay, so 4 still goes into 180 45 times. Well, let's see. 11, 12. So doesn't 3 go into 147 and 45? How did I just figure that out? That 3 went in there.
3 goes into 45, 50.
But how did I figure out that it went into 147?
It goes into 12.
It goes into 12 because I added them up. I was hoping 9 would, but 9 doesn't, does it? Okay, so 3 goes into 14 4 times. And 9. And then this would be 1 and 15. So I get 49 pi over 15. And I'm okay with just leaving it like that. If it says to give you a decimal, then put it in a calculator. Okay? Questions? Okay. So, sector of a circle, the region bound by blank radii and intercept an arc. So a sector is the whole thing. So how many radii enclose this sector right here? How many radii enclose that sector? 2. Because you have this side, PC, and PB.
Oh, yeah, that's right.
Okay, so 2 radii enclose and they intercept an arc. That's what a sector is. The sector is the portion of the circle. So how many sectors is this circle divided into? 4. Okay. Oh, but what if I added these two together? Is that 5? No, if I 1, 2, 3, 4, yes.
Yeah.
But then I could put these two together and that would be a 5th one. And then I could put these two together and that would be a 6th. And I could put these two and it'd be a 7th, 8th. So can I add to them? The only thing you can't say is a sector is the whole thing. Because the whole thing's a circle. Okay? So, let's see. What's the area of a circle? 360? No. What's the area of a circle?
Square root A plus pi r squared.
Pi r squared. So pi r squared is my area of a circle, yes? Okay. So using the same magic I just used on the last one, we are going to do theta for the area of a circle sector, sorry. Area of a sector, we still use an A. We're going to use theta over your 360. Why am I using theta over 360?
The angle.
It's the angle, it's the portion of the circle I have, yes?
Mm-hmm.
So it's the ratio of the area. So of the area means I have to multiply. So it's the fraction of the total area. If this sector is an eighth of this circle, wouldn't its area be an eighth of the whole circle? Yes. Okay, so area of the sector is right here. So it says, what is the area of the sector? So, well, A equals theta pi r squared over 360. So what is theta? 165. I guess it didn't tell me which sector did it, but we're going to say this one. Could we do this side too? Yeah, because we could subtract from 360. Okay, so A equals 165 times pi times r squared. What's r?
3.
3, so 3 squared is
9.
9 over 360. So what do you want to reduce by, 9 or 5? 9? Okay, so 9 goes into 36 how many times? 4. With 0 left over. Well, I know 5 goes into 165 and 40, right?
Mm-hmm.
And 8 definitely doesn't go into 165. How do I know that? Well, it's an odd number, right? So I know 8 doesn't go in there. So 5, so that's 8. And then 5 goes into 16 3 times, carry a 1. So 33. So area equals 33 pi over 8. And I am going to make you do square units. Because it's area, yes? Yes? An area always gets a square. And if I don't write it, I will forget it, won't I? Pretty sure on your homework you have the units. Where would I get the units from?
Label?
Which label? The radius?
Yeah.
Okay. You guys want to try this one on your own?
Yeah.
Okay. You do it. Okay, so did you get 295 pi over 18 units squared? Or square units?
I got the top one.
How'd you get the top and not the bottom? Because if you got this to be 5, then you had to divide this by 2.
Yeah. I got that, but I don't know the bottom.
because
What's the answer?
what?
What's the answer?
Right here. 295 pi over 18 units squared. Okay, I took 100 and 360 and I reduced out a 0. Did you guys reduce out a 0? Hopefully. And then 10 and 36 both had a 2, yes? So half of 10 is 5, half of 36 is 18. So 5 times 59 is 295. That's what I got. Did you guys get 295? Pi over 18.
I just didn't multiply.
Okay. Yep, make sure you multiply. Questions on that? So what are your two formulas? It's the first formula. What's its name?
Arc length,
Arc length. And second one is
area,
area of a circle. Okay, your last notes are just some vocabulary. We're going to match them up. You have this sheet, right? Okay. So, what is AB?
the center.
No.
Oh, it's the
Ooh, this one we didn't go over. We didn't talk about it already. You should know what it is.
Semicircle.
It's a semicircle. Why is it a semicircle? Because it's half of a circle. Should you have known that?
yeah.
Yeah, but you guys were stuck on like what everything else was, right? Okay. So what's this shaded area?
Sector of a triangle
Sector of what?
or of a circle.
Sector of a circle. I know. I was like, what? Sector of a circle. What's theta?
Central angle.
Central angle. No.
Mm-hmm.
Because I put the arc there, they didn't. Correct?
Yeah.
So look at 4. Isn't that a central angle? Yes?
Yeah.
Okay, this is a central angle. You aren't going to know that other one, I will tell you. After I saw this picture, I'm like, that can't be central angle. Okay, theta is in radian. It's right under central angle. That's weird. What?
I originally put that down before you said central.
Oh, really? Why?
I don't know.
Oh, he just had a feeling.
Yeah.
Okay, so n degrees. I think that's the arc measure. What do you think? Okay. And arc ABC.
Major arc.
Major arc. Why is it major?
It's bigger arc.
It's more than half, right? So that means CB is the minor arc. And what is, it's written a little bit different, but what's this equation?
It's arc.
Arc length.
Arc length. And how did we write it? Let's write it how we wrote it. Theta pi r over 180
Oh yeah, when I
because it reduced. Okay, and arc length, right? Is that what they have? Yep. I was trying to use their words. What is the other thing we could call it instead of arc length? Sector length? Bless you. Okay, and 9. Well, the only thing we have left is what? Segment of a circle. And if you have that, doesn't that make sense? It's kind of weird, but... Okay, so that's it for today's notes, and I will get you your worksheet. Isn't it a worksheet? No, it's a book assignment. Sorry.